Hello viewers, today we talk about what's the matter with the universe. Scientists have the answer. Let's start. A team of US astrophysicists has produced one of the most precise measurements ever made of the total amount of matter in the universe, a long-time mystery of the cosmos. The answer published in the Astrophysical Journal on Monday is the matter consists of 31.5%, give or take 1.3% of the total amount of matter and energy that make up the universe. The remaining 68.5% is dark energy, a mystery force that is causing the expansion of the universe to accelerate over time, and was first inferred by observations of distant supernovae in the late 1990s. Put another way, this means the total amount of matter in the observable universe is equivalent to 66 billion trillion times the mass of our Sun. Muhammad Abdullah, a University of California Riverside astrophysicist and the paper's lead author, told AFP, "Most of this matter, 80%, is called dark matter. Its nature is not yet known, but it may consist of some as yet undiscovered subatomic particle. The latest measurements correspond well with values previously found by other teams using different cosmological techniques such as by measuring temperature fluctuation in the low energy radiation left over from the Big Bang. This has been a long process over the course of 100 years where we gradually getting more precise." Gillian Wilson, the study's co-author and a professor at UCR, told AFP. "It's just kind of cool to be able to make such a fundamental measurements about the universe without leaving planet Earth," she added. The team honed a 90-year-old technique that involves observing how galaxies orbit inside galaxy clusters, massive systems that contains thousands of galaxies. These observations told them how strong each galaxy cluster gravitational pull was, from which its total mass could then be calculated. "In fact," explained Wilson, "their technique was originally developed by the pioneering astronomer Fritz Zwicky, who was the first person to suspect the existence of dark matter in galaxy cluster in 1930s. He noticed that the combined gravitational mass of the galaxies he observed in the nearby Coma galaxy cluster was insufficient to prevent those galaxies from flying away from the another, and realized there must be some other invisible matter at play. The UCR team refined Zwicky's technique, developing a tool they called Galvade that determines more accurately which galaxies belong to a given cluster and which do not. They applied their tool to the Sloan Digital Sky Survey, the most detailed three-dimensional maps of the universe currently available, measuring the mass of 1,800 galaxy clusters and creating a catalog. Finally, they compared the number of clusters observed per unit volume in their catalog against a series of computer simulations, each of which was fed a different value for the total matter of the universe. Simulations with too little matter had too few clusters, while those with too much matter had too many clusters. The Goldilocks value they found fit the simulation just right. Wilson explained that have a more precise measure of the total amount of matter of the universe may take us a step closer to learning the nature of dark matter, because we know how much matter we should be looking for when scientists carry out particle experiment, for example at the Large Hadron Collider. What's more, the total amount of dark matter and dark energy tells us the fate of the universe, she added, with the current scientific consensus being what we are headed for, a big freeze where galaxies move further and further apart, and the stars in those galaxies eventually run out of fuel. That's enough for this video. Please subscribe my channel and press bell icons for more updating videos. Thank you.